Hello, and welcome to the next part of my video walkthrough for the VCAA Exam 2 from 2019. We're looking at Module 4, which is Graphs and Relations. We've got a graph here. Graph below shows the membership numbers of the Wombatong Rural Women's Association each year for the years 2008 through 2018. Question A, how many members were there in 2009? Well, 2009 is there. Scroll up. There's the dot. What's it next to? 60, 60, done. Show that the average rate of change from members in 2013 to 2018 was -6 per year. Average rate of change. All right, so what we need to do is average rate of change means we're talking about a gradient. So what we want to do is we want to do a gradient equation. y2 minus y1 over x2 minus x1. So in this case here, y2 is going to be 32. It's that there. So it's 2018, comma 32. We want y2, which is that one there, minus at 2013, where it was 62. So that's 2013, comma 62. So it's 32 minus 62 divided by 2018 minus 2013, which is minus 30 over 5, which is minus 6. Shown. If the change continues at this rate, how many members will there be in 2021? Well, there are currently 32 in 2018. So then you can go, well, okay, 2019 is going to be 6 less than that. That's 26. 2020 is 20. And then that leaves 2021 as only having 14 members. Each branch pays an annual fee based on the number of members that it has. To encourage each branch to find new members, 2 annual fee systems have been proposed. Proposal 1 is shown in the graph there, where the proposed annual fee is per member is displayed for branches up to 25 members. What is the smallest number of members that a branch may have? Well, number of members, the smallest number that shows up on here is this one here. Well, what number is that? Well, I've got 1, 2, 3, 4 there. Therefore, it's 3. A number of members required to meet a particular inequality. Complete the inequality by writing the appropriate symbol and the appropriate number. Well, this is the $10 one. So here's the $10 one. This is where we're looking. We're looking here. This bracket ends at this point here with a solid dot. So that means it's going to be equals to, and then what's it above? Well, it's above 10. Done. Proposal 2 is modeled like this, which we've got here. We've got an equation, negative 0.25 times the number of members plus 12.25. What they want you to do is they want you to sketch that and then draw that on the graph yourself. So if you have no members, then ostensibly it would cost $12.25 because this is the gradient and this is the constant. So that's 13. So it's about there. That's where that point will go. Now what we want to do is we want to actually draw that graph properly. So we'll go main, graph and table, clear all. Now we could spend all this time mapping out that one as well. We might have to, we might not. One of the tricks to using your time appropriately is to not do anything unnecessary. All right. Yes, it might be tempting to just put that graph in the step graph into your CAS as well, but you might not need to. So we'll see what happens. So the annual member fee is going to be Y, and we'll go 0.25 times X, where X is the number of members, plus 12.25. And obviously my window isn't set up correctly, so I'm going to clear all, and we'll go back up here and we'll try and draw it again. So 12.25, and let's just see if we can find out where it intersects. Well, remember that the graph only goes, our axes only go as far as 25. So if we can figure out where 25 is on this one, and at 6, so when x is 25, y is equal to 6. Well, when x is 25, y is equal to 6. There it is on my graph, which means that if I get my ruler out and I draw a straight line that connects those two dots, and I connect those two dots, then that's going to answer the question for me. I have now drawn the graph, and then you would label it proposal 2. And then what some people do is they'll also highlight the endpoints. So this one here is 0, 12.25, and then this one down here is 25,6. The last part of the question says they have the same annual fee per member for some values of the number of members. So proposal 1 and proposal 2 cost the same at some points. Where? Well, the same means that they're generally looking for intercepts or intercept points. Well, if I look at my graph here, I don't need to draw it on my CAS because I've used a ruler and I've estimated where everything is properly. Well, that there, and that there cleanly overlap with the lines that are already there. Write down the values of the numbers of members. So that one there is above, 5, 6, 7, 8, 9, 15, 16, 17, and 25 at the end, which we already worked out. Members of the association will travel. This question. I remember this question. Members of the association will travel to a conference in cars and minibuses. X is the number of cars used for travel. Y is the number of minibuses. They can only use a maximum of 8 cars in total, or 8 cars and minibuses in total. They must use at least 3 cars. They must use at least 2 minibuses. It's an odd set of constraints, but it is what it is. Each car can carry a total of 5 people, and each minibus can carry a total of 10 people. Use this information to write inequality 4. So, the important thing to realize is that we still need to be using the same X's and Y's as before. How many people can fit on a car? Well, 5. So 5 times X. How many people can fit in a minibus? 10. And what is the maximum Now you can have 60, but they want the maximum. So you can have less than or equal to 60. And there it is there. So they've graphed those four inequalities for you. Clearly mark with a circle the remaining integer points that can satisfy all four inequalities. What 4 or 5 values, because there's actually 5, that I can pick on this graph. Now, if you were to, first things first, if you were to actually graph that inequality, you're going to have a shaded area. And I'm going to use a highlighter for that. And it's actually going to be, well, that's really thick. It's going to be, that little bit there. It's in that green region. Ignoring any of the accidental spillage. So what points can I have inside that? Remember, you can't have half a bus or a third of a bus. So you can only use whole numbers. And those whole numbers exist on the vertical and horizontal lines. Now, inside my shaded area, I've got that point there. I've got this point here. I've got this point here. This one here and this one here. Now it says mark in circles. So I would just circle them. To get the 1 mark, you would need all 5 points. Now, the next question that they talk about is a constraint or an optimization question. What is the cost for 60 members to travel to the conference? So if you're going to have 60 people travel to that conference, then what you need to do is you need to look at the line 5x plus 10y, not less than or equal to 60, equal to 60. You need to look up at your graph and you need to find which point actually exists on that line. And for the record, it's either this one here or this one here. I'm not sure which one. It doesn't matter. Because if you look at this line here and this line here, only 1 point exists on both. And it's this one here, 4, 4. So that is the number that we should use in this equation here. X equals 4, Y equals 4. Put them into the equation. Now we've got 70x plus 100y. And that's going to give us an answer of 4 times it's 280 plus 400 is going to be $680. What is the minimum cost for 55 members to travel to the conference? So again, we're going to go back to our graph and we're going to try and find which combination of points allows us to take exactly 55. All right, we want to take exactly 55 people to the conference. So using the inequality that we have here before, we have 5 points that we can work with. Well, if we put 3 into this one, 3 times 5 is 15, plus 3 times 10, which is 30. So that's only 45 people. So that's 45 people. This one here, 4 times 3, so that's 20, so that's 50 people. This one here is 5 cars and 3 minibuses. 5 times 5 is 25, plus 3 times 10, that's 55. And then we can check here, 3 times 5 is 15, plus 10y, plus 10 times 4. So this one here is also 55. And the question that they want is the lowest cost. So I have 2 points that I can work with. I can work with either 3, 4 or 5, 3. So 3, 4 or 5, 3. I can use those 2 points. And now put them into this one here. And from there, figure out which one has the lowest cost. So that's 210 plus 400, which is $610. Or I can do 5 times 7, which is 350, plus 300, which is 650. So clearly that one is the better option, and that is the one that you would say is your final answer, 610. But I don't care about what combination, but that is the minimum for that many people. All right, last question. This was actually a hard question. Just before the cars were booked, the cost of hiring each car increased. The cost of hiring the minibus stayed exactly the same. All of the initial constraints applied. What they want to do is they want to change the cost equation by K. And then what they want to do is they want to figure out 6 cars and 2 minibuses. 6, 2. So that's going to be an important point that you need to use. If they have increased the cost of hire a car by more than K, then my cost equation is now C equals 70 plus K times X plus 100Y. Now, if I rearrange this, into a straight line equation, this line has a gradient. This line here, in fact, has a negative gradient. The gradient of the line is negative 70 plus K over 100. If the increase in cost is more than K, then the maximum cost can only occur when I have those points that exist. What I want to do is I want to figure out how to get the gradient equal to -1, get it to less than -1. That is the only way that it will actually touch. So if I put in my values that I've got here, 70 plus K times 6 plus 100 times 2. If I can get this gradient here to be less than -1, then I'm golden. Sorry, this one is actually a bit of a doozy. And this is the sort of question that you will be using to do sort of trial and error on your CAS. What we're going to do is we want to figure out the maximum cost. Can only occur when using 6 cars and 2 minibuses. So the cost at this point is actually kind of irrelevant. because all we know is that it's going to be at a maximum. I could break out the math methods calculus and break it out, but you guys don't have that. For it to be a maximum, we need to have this less than -1. The increase in cost is greater than K if K is 30. If it's 30, so if it's gone up by $30, then the only way any of this works is at 6,2. Because if you put in 30, so basically what they want you to do is they want you to just try and put $30 in, or try putting numbers in. And the reason why they pick 30 is because, well, the goal is to get this to be less than 1. Well, 70 plus K divided by 100 is less than -1. Well, that means K has to be $30. If K is 30, 70 plus 30 is 100, 100 divided by 100. So K has to be more than 30. Right? It's more than 30. Now remember, they've already included the more than themselves. This is a 1-mark question, so technically you don't need to put all this in here. So if you just wrote 30, well, guess what? They give you the mark. Only 7% of students got this question correct. I'll be honest, I'm a bit flummoxed as well myself. But the idea is that this equation when we're talking about corner point principle and we're talking about trying to maximize cost, well, clearly we are looking for corners. Well, if there's a corner at 6,2, like for example, we can say this one is, then any line going through it has to have a negative gradient. All right. All of the other constraints still apply. So if we go back up and we look at our graph, there's 6,2. What is the gradient of the line that sits on? Well, it goes from 0,8 to 8,0. Well, that means it's a gradient of -1. Which is where they got that -1 from. So as long as that line, or as long as the K value is changing by more than enough to make the gradient less than -1, then that's where the only place the maximum can occur. So you have this, I'm just going to rewrite it out here. You have this strange relationship here that you would then need to solve. -70 plus K is less than -100. A negative and a negative, they can drop off and cancel out. And you subtract 70 from both sides, K 30. Now, because I divided by -1, I also have to make sure that I flip the symbols around, which is what a lot of people forgot to do. Sorry, that one was a little bit more rambly, but thank you for watching.